students. So here I am your Arka Sir. So I have come with another new and fresh episode on physics. So students, in my previous episode if you have seen, I have discussed about the KCL and KVL, and we will do the numeric problems and the potentiometer and all. Okay, but before that I think we should start the magnetic effect of current electricity. So if we can complete this chapter, then we will move to that portions again. Okay. So before we start the class, I want to wish all of you a very happy Independence Day. Okay, to all of you, to all my viewers, to all my friends, to all my students. Okay, and today is the 15th of August, the Independence Day. So hope you all will celebrate that in your school or at your home. So let be together. Okay, and we should enjoy our life and we should enjoy our future, which should be a very good. Okay, if you can study hard, if you can be a good human being, so we can make our future bright. We have to be a good human being first of all, and we all have to respect each other. Okay, so that is the basic thing we also needs to learn apart from the academics. So without further delay, so let us now move to the today's topic. Clear? So today my topic is magnetic effect of electric current. So before we start the topic, I will give you some basic idea. So I think you have that, but still I will give some basic idea and then I will move to the topic. So now before we start the topic, what we will do, what is magnet? Okay, so a basic idea of the magnet, okay, that you all know, the things, the materials which can attract other magnetic substances is known as magnet. The magnet has two poles. This is the north pole and south pole. So what is magnet? A material which can attract the other magnetic substances. Those materials are known as magnet. Clear? So magnets are of two types. One is known as the natural magnet, and another is known as artificial magnet. Okay, artificial magnet. Clear? So natural magnet means the magnet which can be found naturally is known as the natural magnet. Clear? And what is artificial magnet? The magnet which we can prepare. Okay, basically the electromagnets. Okay, electromagnet. By if we flow the current through some materials, clear, then that materials will become a magnet. So that is the electromagnet. So these two type of magnets are there as per their sources. So one is natural magnet which is found naturally, and another is known as artificial magnet. Clear? So what are the properties of the magnet? So now let us quickly revise. So basically this is revision. Okay, the magnet you have learnt in the previous classes. I think class 4, 5, 6, 7 it is there. So now we will learn some properties of magnet. Properties of magnet. Clear? What is the properties of some magnet? Okay, of a magnet. Clear? So which one? What is known as the two end of a magnet? Magnet where the force of attraction to end, or you can also say it as point. Okay, point where force of attraction is maximum is known as pole of a magnet. Okay, it is known as pole of a magnet. Clear? The two end or the point of the magnet, suppose this is the magnet, a bar magnet. Okay, so at the two end or the point where the force of attraction is maximum, so these are known as the pole of a magnet. Clear? So now if a magnet is suspended freely by a thread, then the pole which is directed towards north side of earth is known as north pole, and the pole which is directed towards south pole of or south side of earth is known as south pole of that magnet. That means what? The 2 points will be there in a magnet where the force of attraction will be maximum. Clear? So that 2 points are known as pole of the magnet. Okay. So these 2 points are the pole of a magnet. So now if a magnet is suspended freely, clear, then what will happen? Then by a thread, then the side which will be directed towards the north side of the earth is known as the north pole of the magnet, and which is directed towards south side of the earth is known as the south side of the magnet. That means what? If a magnet is suspended freely, suppose a bar magnet, then the north pole will always be directed towards the north side of earth, and the south pole will always be directed towards the south side of earth. Clear? So this is what? This is the 2 properties. Other properties are also there. So first of all, what? In a magnet, the 2 point where the force of attraction will be maximum is known as what? The pole of the magnet, and the north pole will be directed towards the north side, and the south pole of the magnet will be directed towards the south side. Or the pole which will be directed towards north side of the earth is known as the north pole, and the pole which will be directed towards the south side of the earth is known as south pole. Clear? Now let us start point number C. So this is the 2 point. Now let us move to point number C. What is other properties of a magnet? Okay. What is the other properties of magnet? Now point number C. The same pole, similar, or we can write similar pole. Pole attracts, similar pole repels, and opposite pole attracts each other. Okay. So this is a very important properties of magnet. In case of the current electricity, the same charge will repel each other, and the opposite charge, positive and negative, will attract each other. Here the 2 south pole or 2 north pole will repel each other, but 1 south pole and 1 north pole will attract each other. So suppose we have a magnet, this is north pole, this is south pole, and suppose this is south pole, this is north pole. So they will attract. Here it will be attraction. Okay, attraction. Clear? Between the 2 opposite pole. But suppose here it is N, it is S, and it is also N and S. So it will be what? It will be repulsion. Okay, repulsion. That means what? 2 opposite pole. It may be south south, it may be north north. So they will repel each other, and opposite pole will attract each other. Clear? The similar pole repels and the opposite pole attract each other of a magnet. Now let us move one more questions. Okay. For your information I am giving this. So what I told in the point number B, that if a magnet is suspended, suppose a bar magnet, okay, bar magnet means rod shaped magnet. Clear? Bar magnet means rod shaped magnet. Okay, so it is a bar magnet. Clear? So magnetic needle means this type, this shape. Okay, this shape is known as magnetic needle. Clear? Which can, if we have a stand, then the magnetic needle can, suppose it is north pole, it is south pole, it can rotate. Clear? So this is known as the magnetic needle. Clear? Now the horseshoe magnet, these are basically the shape. Okay. So suppose it is north pole, it is south pole. Okay. So these are the horseshoe magnet. Clear? So these are according to the shape, the different type of magnets are there. Okay. So it is magnetic needle. Okay, magnetic needle, it is bar magnet, it is horseshoe magnet, like this. Okay. Now one very common thing can be asked, okay, during the examination or any competitive examinations, okay, that why magnetic north pole, or why north pole of a magnet, simple, north pole of a magnet and south pole of the magnet always directed towards north and south pole, south pole of earth respectively. Okay. That means in the property we come to know that if a magnet, in property we come to know that if it is a magnet and suppose it is north side, it is south side, it is east, it is west. Clear? It is north pole of the magnet, it is south pole of the magnet. So why the magnet, if it is suspended freely, then the north pole of the magnet will be directed towards the north side, the north pole of earth, and the south pole of the magnet will be directed towards the south pole or south side of earth. Clear? So it is why? Because earth is itself a magnet. Earth itself is a magnet. That means what? The earth have also two poles. Any magnet have two poles. Clear? One will be north and another will be south. So so this is what? This is geographical north pole and this is geographical south pole. Clear? Of earth. But actually in the, if earth is considered as a magnet, huge magnet, so the magnetic south pole of earth is situated at the geographical north pole of earth. Clear? Am I clear? So the magnetic south pole, this is what? Magnetic south pole of earth. Okay. And the magnetic north pole of the earth is situated, at geographical south pole of earth. So that will be what? This will be geographical, this will be magnetic north pole of earth. So how we can prove that earth is itself a magnet? If you buried a piece of iron inside the soil for a few months, if you are taking it after few months, then it will become a small or weak magnet. Magnetism property it will acquire. Okay, why? Because the magnetic line of forces are there for in case of the earth also. Clear? What is magnetic line of force? After these questions I will come. Okay, and what is magnetic field? Now, so suppose, so here it is geographical north pole or north side of earth, it is geographical south pole or south side of the earth. Now earth is itself a magnet. So earth is itself, suppose this is the earth is itself, it is what? North pole, it is south pole. Clear? And here the magnetic south pole of earth and here magnetic north pole of earth is situated. Clear? So magnetic south pole of earth is here situated and magnetic north pole of earth is here situated. Now what we know? That the opposite pole will attract each other. Now actually this is the magnet. So this magnetic north pole and earth magnetic south pole will attract each other, and this magnetic south pole of magnet and the magnetic north pole of earth will again attract each other. Clear? So that's why what will happen? the north pole will be directed towards north and the south pole will be directed towards geographical south of earth. Clear? So this is the reason why the north pole will always be directed towards the north side of earth and the south pole of a magnet will be directed towards the south side of the earth. Okay, so compass, based on this property, the device is compass. Clear? So basically it is used in the aeroplanes as well as the ship, where the pilot can identify which direction they are going, which is the north direction, south direction, and if we can identify north and south, easily we can identify what is east and west. Clear? So that is the reason. So I am explaining once again. In geographical north pole of earth, the magnetic south pole is situated, and if geographical south pole of earth, the magnetic north pole is situated. Now the north and south will, the opposite poles will attract each other. Clear? That means magnetic south pole of earth will attract the north pole of the magnet, and magnetic north pole of earth will attract the magnetic south pole of the magnet. So that's why it will always be directed towards the north and south direction. Now if you can identify it clearly, means very precautionally and with full attention, then you can see that it will not be directed exactly at north side and south side, because a slightly inclination will be there. Clear? Why? Because this pole actually it's not situated here overlapped, it is situated slightly this side, and it is situated slightly that side. Clear? So that's why it will be slightly inclined, okay, in north and south direction. Why? Because the position of the exact position of the magnetic north and south pole of the earth is not accurate to the north and south pole, okay, the exact point, it will be slightly inclined. Clear? So that's why the magnet will be slightly inclined towards the north and the south direction. Clear? So this is the reason. So hope you have understood this. Now let us move to the next topic. Let us move to the next topic. Now, what is magnetic field? In the current electricity, I have discussed what is electric field, and here it is what is magnetic field. What is, if you can recall current electricity, what is electric field? If a conductor is carrying current, then the what area around it in which the effect of this particular charge can be experienced. So this is known as the what? Electric field. Clear? Now in case of the magnet, suppose we have, let me first explain. Suppose we have a bar magnet. Clear? If we are keeping magnetic material, suppose this is the magnetic materials, okay, this is the magnetic material. So suppose is the bar magnet and this is the magnetic material. So if it is kept very far, then what will happen? It will not be attracted. But when we are bringing it close, but after a certain distance it will be attracted. Clear? That means what? There is a zone around it. There is a zone around it in which the property of the magnet can be experienced. That means any magnetic material if you keep, then it will be attracted by the magnet or it will feel a force. Okay. So this is this area. Clear? This area is known as magnetic field. Okay. So it's very easy. So what is magnetic field? Okay. So the area around a magnet where the influence of that magnet can be seen is known as magnetic field. Clear? So it's known as magnetic field. So hope you have understood what is magnetic field. Now before going to the magnetic line of force, one very common questions, and in the earlier classes also, class 4, 5, 6, these questions you might know this or you have gone through this. what is that? Why repulsion is best technique to identify a magnet. Okay, why repulsion is the best technique to identify a magnet? Suppose I have given two, I don't know, I have given two substances, they are looking like almost same. Clear? Now one is magnet and another we don't know whether it is a magnet or magnetic materials. Okay, so here I told you that, okay, this black color marker is a magnet, suppose, and this we don't know, red color marker, whether it is a magnet or magnetic materials. Clear? Now if we bring near and we see that it is attracted by this. Okay, now what we know, the opposite pole also attract, and also magnet can attract other magnetic materials just like iron, cobalt or nickel, whatever. Clear? So if it is attracted by the magnet, that means it may be a magnet, may be a magnetic materials. That means by watching the force of the attraction property, we cannot say whether it is a magnet or a piece of iron or any other magnetic materials. Clear? But if it repels, if it is if it is brought very close and repelled, then what? The magnetic materials cannot be repelled by a magnet. Now what will happen? That means only the same pole of the magnet repels each other. That means if we see the repulsion between these two materials, that means one is magnet, that means this must be a magnet. Why? Because only the opposite pole of the magnet repels each other. Clear? So that means what? Suppose it is south pole and it is north pole, then what will happen? They will attract, it will attract, and suppose it is a magnetic material, then also it will be attracted by this. Clear? But if we see repulsion, then what? The same pole, only the same pole will repel each other. Clear? So by repulsion, if we see the repulsion, then definitely we can say that this is a magnet, because the same pole can be there if and only if it is also a magnet, otherwise the same pole is not possible. Clear? So that is why the repulsion is the best technique, okay, to identify a magnet. Clear to all of you up to this? Now let us come to the magnetic line of force. What is magnetic line of force actually? Okay, what is magnetic line of force? So remember, magnetic field is a vector quantity. Clear? Why vector? What is scalar and vector quantity? Scalar quantity means the quantity which have only a value or magnitude, but don't have any specific direction. Speed means if a particle is moving in any direction and traveling some path, so that is means what? The speed, the path travelled by unit time in any direction. That means it is a scalar quantity. Clear? So magnetic field, basically magnetic field is a vector quantity. Why? Because it has a particular direction. Okay, so magnetic field, that means what? If it is attracting something, okay, towards its pole, that means what? The force of attraction, force is a vector quantity, so it will attract something. Clear? So it must have a value as well as a particular direction, so it is a vector quantity. And scalar quantity means the quantity which don't have any particular direction, only have some value or magnitude. Clear? So the magnetic field is a vector quantity. Now what is magnetic line of force? Magnetic line of force, or it is also known as magnetic flux. Okay, what is magnetic line of force or magnetic flux. Clear? Basically, it is an imaginary line. Clear? So, it is an imaginary line. Okay. So, if we keep a magnet and if we a bar magnet and if we give some iron dust on it and then shake it properly, clear, iron dust on the board and they shake it properly, then we can see some formations, okay, of the curved lines. Basically, these lines are known as the magnetic line of force. So, it is an imaginary line, clear. So, it is an imaginary line. Suppose I am drawing one diagram, it is a bar magnet and it is north pole and it is south pole. So, we can see some imaginary lines like this, okay. So, we can see some imaginary lines like this, clear. So, it will be generated from the north pole and it will enter in what? South pole, clear. It will enter in south pole. That means the direction will be from north pole, originated from north pole and it will enter in south pole, clear. So, this is known as magnetic, this line, imaginary line, it is known as magnetic flux or magnetic line of force, okay, force. Basically, due to the presence of this line, due to the, suppose this is the area around the magnet where the magnetic line of force are there, clear. So, due to this presence of this magnetic line of force, the magnetic field actually develops, clear. That means due to this line, why the line is absent here, the line is not there, here this imaginary line is not there, okay, no existence of this. So, here if we keep a piece of iron over here, then it will not feel any force of attraction, clear. If we keep a piece of iron over there, then it will feel a force of attraction, okay. That means due to the presence of the magnetic line of force, the magnetic field will be generated, okay. So, what we will write in short, as you can consider it as a definition of the magnetic line of force, okay. What we can write as a definition of magnetic line of force, clear. So, the imaginary lines which will be originated from north pole of a magnet and enters into south pole of that magnet without intersecting between any two lines is known as magnetic line of force. Magnetic line of force or magnetic flux, clear, okay. So, this is known as magnetic line of force or magnetic flux. So, what is magnetic line of force? The imaginary line, I draw that before, the imaginary line, okay, which will be originated from the north pole of the magnet and enters into the south pole of a magnet, clear. So, these imaginary lines and never intersect. Suppose this is the line number 2. So, they will never intersect with each other, clear. So, these imaginary lines, and due to this line actually the magnetic field exists, okay. So, these lines are known as the magnetic line of force or magnetic flux, clear. So, hope what is magnetic line of force now you can answer or you have understood, clear. Now, let us move to the next topic. So, students, now what will be the direction of the magnetic field at any point, okay, inside that field, clear. So next point is direction of magnetic field at any point in that field. Okay, what will be the direction of the magnetic field? If it is a part of circle and we draw a straight line on the point of this particular portions of the circle, which will intersect the circle in only one point. It cannot intersect in 2 points. Clear? So that is known as tangent. Okay. So if a circle is there, a part of circle is there, and if we draw a perpendicular, okay, on that particular point, which will intersect only at a single point on the circle, it cannot be intersect in 2 points. Okay. So this is known as the tangent. Clear? So in mathematics, if this topic I will discuss, then obviously what is tangent I will discuss, and some sums are also there on this property. Clear? So what will happen? Now come to the topic, what is magnetic direction of the magnetic field. So now what will happen, if we draw a tangent okay, on the magnetic field, then the direction of the tangent will determine or will indicate the direction of the magnetic field at that particular point. And remember, in a particular point, for a particular point inside the magnetic field, the direction of the magnetic field will be same. That means it cannot be others. The same point, one direction and another direction. Okay, for any other point direction is there. So from the same point, for the same point inside the magnetic field, the multiple directions of magnetic field is not possible. Clear? So what will be the direction of the magnetic field? If we draw a tangent on the point of a magnetic line of force, then the direction of the tangent will determine or will indicate the direction of the magnetic field at that particular point. Clear? Now we will come the properties of the magnetic line of force. That is very important for the examination. Okay, board exam. Okay, the properties of magnetic line of force. So it is properties of magnetic line of force, or what is the name, you can understand, magnetic flux. This is another name. Clear? The properties of magnetic line of force or magnetic flux. Clear? So first property already we have discussed. The first property, it will be originated from north pole of a magnet and enters into south pole of the magnet. Clear? Already I have discussed. So magnetic line of force or magnetic flux will be originated from north pole of a magnet and enters into south pole of that magnet. Clear? And enters into south pole of that magnet. Clear? So this is what? This is the first property of magnetic line of force. Now number 2 or point number B. Okay, two magnetic flux cannot intersect each other. Okay, so very important. The reason is can also come, but we will learn separately why the two magnetic line of force cannot intersect each other. Okay, so the second point is two magnetic line of force, that means suppose this is the magnetic line of force and this is also a magnetic line of force, they intersect, which is not possible. Clear? So, two magnetic line of force cannot intersect each other. Clear? So, here suppose it is one magnetic line of force, it is another magnetic line of force and they intersect at this point. It is not possible at all. Clear? So, the two magnetic line of force cannot intersect each other. Now, the next one, number C. What is number C? If the magnetic field is uniform, then the distance between magnetic fluxes are almost equal and they are almost straight lines. Okay, that means uniform magnetic field means they are in any points. Okay, the value of the magnetic field is equal. So, in that case the magnetic line of force will the distance between them will be always is almost equal. Clear? And they can be considered almost as a straight line. Clear? In case of the uniform magnetic field, and if it is not uniform magnetic field, then the distance of the magnetic line of forces will not be equal in case of the other lines. Clear? Or fluxes, and they will also not be a straight line. Clear to all of you? Okay. Now, the next point. So, I am rubbing the point number 1 and 2 and also 3. Clear? So, the first point what I told, that magnetic line of force or magnetic flux originated from north pole and enters into south pole of the magnet. Two magnetic line of force cannot intersect each other. Number 3, what I told, number 3, that in case of the uniform magnetic field, the distance between the two magnetic line of forces or among other magnetic line of forces are almost equal. Okay, and also they are almost straight line. Now, the next one, number D. If we have taken an unit area of that particular inside the magnetic field, then the number of magnetic line of force, okay, passing through that particular unit field, unit area in that inside that field is known as what? Flux density. Okay. So, if we take a unit area inside a magnetic field, then the number of magnetic flux passes through that area is known as flux density. So, if the flux density increases, then the field strength will also increase. If flux density increases, then field strength will also increase, and if it decreases, that means vice versa, then field strength will decrease. That means where we can see more amount of or density of the magnetic line of force, there the field strength will increase, and where we can see less amount of magnetic line of force or less dense of magnetic line of force, there the force of magnetic field will decrease. Clear? So, these are basically the property of the magnetic line of force. Now, let us move to the very important questions, that in the property we have written why the two magnetic line of force cannot intersect each other. Okay. So, these questions very common one may come in the examination. Why two magnetic line of force never intersect each other. Clear? Never intersect each other. Okay. Now suppose this is one magnetic line of force, that is another magnetic line of force. Okay, coming from the originated from the same magnet. Suppose they intersect each other. Okay. So suppose this is the common point A. At common point A they intersect each other. Now for this line, if we draw tangent, so this will be the direction of tangent, and for this line if we draw a tangent, then this will be the direction of the tangent. Clear? So that means what? For the two curved lines, clear, it can be considered as a curved line. So for the two curved lines, they are meeting at the same point. So from that same point, for two curved lines, the two tangents can be drawn for the two lines. Okay, point is common, but the tangent for the two curved lines can be drawn. That means if suppose the two magnetic line of force intersect each other. Clear? So from that particular point, for the two magnetic line of force, we can draw two tangent, and the direction of the two tangent will be different. That means, what does it mean? That means from the same point, okay, both the tangent actually directing the direction of the magnetic field, and the direction is what? Not same, different, which is not possible. I already told that from a particular point, the direction of the magnetic field should be in a particular direction, not in different direction. So here the two magnetic line of force identifying the, or it is representing the two different directions, clear, of the magnetic field from the same point, which is not possible. Clear? So that's why the two magnetic line of force cannot be intersect each other or never intersect each other. Clear? So I am telling once again, if the suppose two magnetic line of force intersect each other at a particular point, so from that particular point we can draw two tangent, and the direction of two tangent will be different. That means what? From the same point it will represent two different direction of the magnetic field, which is not possible. Clear? That is why the two magnetic flux or magnetic line of force cannot intersect each other. Clear? So hope up to this you have understood. Clear? Now let us move to the next topic. Okay, two magnetic line of force cannot intersect each other. It is now clear. Okay. So now let us move to the next topic. So students, now here, now we will learn the effect on a magnet, the effect on a magnet due to a current carrying conductor, due to a current carrying conductor. The effect on a magnet due to a current carrying conductor. So this experiment actually observed by Christian Orested. Okay. So that is why it is also known as Orested experiment. Orested experiment. Clear? So this is also known as Orested experiment. So what we can understand, if a current carrying conductor, if a conductor is carrying a current, then if we keep a magnet basically a needle magnet, clear, near it or beneath it or above it, then we can see the deflection of the magnet, clear. Why? When the current is not carried by the conductor, when no current is flowing, if we keep it, then no deflection of the magnet will be there, okay. But when the current is flowing, then we can see a deflection of the conductor, clear. So suppose this is what, for your understanding I am drawing like this, clear. It is a conductor AB, so it is figure number 1, and no current is, suppose okay, so it is north pole, it is south pole, clear, and it is a magnetic needle which can rotate freely on this particular axis, clear. So here no current is flowing, nothing, okay, it will be directed as it is, okay. Now suppose it is figure number 2, the same conductor AB, clear. Now so previously it was like this, so it is now north pole, it is south pole, clear. So that means what, there is a deflection of the magnet, we can see. So there is a deflection of the magnet, we can see, okay. So there is a deflection of the magnet, we can see. So when no current is flowing, so no deflection will be there. When the current is flowing, then a deflection will be there. Suppose this is a current carrying conductor and this is the magnet, clear, and this is north pole, this is south pole, and the current is flowing from this direction towards the cap, okay. So what will happen when no current is flowing, then it is like this. When the current is flowing, then we can see the deflection of the magnet, okay. This is what, angular deflection, clear, because an angle will be created. So this is an angular deflection of the magnet can be seen, clear. If we stop the current, again it will come like this. If again the current is flowing, again it will be like this, clear. Now what happened, if we increase the amount of current to flow through this, more deflection can be seen, clear. If we decrease the amount of current, okay, through this, less deflection can be seen, clear. If the amount of current flowing through this is more angular deflection, if it is less angular deflection, clear. Now if we now reverse the flow of direction of current from here to here, then what, it will be also reversed. Previously it was like this, and now if it is reversed from cap to this, then the deflection will be also opposite. Now the direction is same, okay, deflection is like that. Now if we keep it at the top, then the deflection will be also opposite, clear. So these are the basic things, okay, from this experiment, clear. So what we know, if the amount of current flowing through the conductor increases, then more angular deflection can be seen, clear. If the amount of current flowing through the conductor increases, more amount of current, then more angular deflection can be seen, okay. So this is observation number 1, clear. Now let us move the observation number 2, okay. What is observation number 2? If the direction of flow of current is opposite opposite than before, then the angular deflection will be opposite. Then the angular deflection will be opposite. That means, as I told, so it is a current carrying conductor. It was like this. Clear? If it is opposite, then it will be like this. Now, clear? So, if the direction of flow of current not from A to B but from B to A, then it will be opposite. Clear? So, the angular deflection will be opposite, okay, than before. Now, point number 3. If the direction of flow of current is unchanged, but the magnetic needle is kept above. It was beneath, now it is above the current carrying conductor, then what will happen? The angular deflection will be opposite than before. Clear? So, that means what? The conductor was at the top and the magnet was at the bottom. Now it is reversed. Clear? So, previously it was like this, now it will be like this. Then also the angular deflection will be opposite than before. Clear? This is the point number 3. Now the magnet is kept at the top and it will be kept at the bottom. Then also but the direction of current is not changing, it is same. Clear? Then we can observe that the deflection will be opposite. Okay, where we can see here at the bottom, this is the deflection and here this will be the deflection. Clear? When the direction of the current is fixed, that means it is not changing. Okay. Now, the point number 4. Point number 4. I have not seen this in the many of the books. This point number 4. Clear? But you should write this. Okay? If both the direction of current as well as the magnetic needle is kept above the current carrying conductor, then no change of direction of angular deflection will take place. That means what? What I told, understand. This is a wire and this is a magnet. Suppose the current is flowing from bottom to cap. So, this will be the direction deflection. Now, if direction is changing, this will be the deflection. Now, if direction is not changing, this was the deflection. If it is kept up, then this will be the deflection. Now, I am changing the both. Okay, when it is coming to like this was the deflection. Now, I am keeping it up, and also I am changing the direction. Both I am changing. Now, what will happen? it will be same. So, the deflection what was before at the bottom, if we change the both the things, means direction as well as the position from bottom to top, clear, then what will happen, both the for both the cases negative, negative, positive, that means what, nothing will change. Okay, so the deflection, angular deflection will not change, clear. So, this is also very important point. Okay, the angular deflection will not change. So, this is also very important point. So, hope okay, you have understood these 4 observation from the Orested experiment. But students, here which direction a current is flowing, if the current is flowing from which to which direction, and deflection will be at which direction, okay, north pole will deflect at which direction, south pole of the magnet will deflect on which direction, that from this experiment we cannot determine. Okay, so there are different rules are there for that. So, today only we will discuss one rule, and the next rules, okay, as well as the Biot-Savart's law, okay, we will discuss in the next episode. So, all the episodes will be very much interesting and you will come to know many things. That is why I will suggest you to follow all the episodes from first to last. Okay. So, now it is first we will learn their Ampere's swimming rule. Okay, Ampere swimming rule, clear. So, suppose this is a person, clear, and where he is swimming, and this is a current carrying conductor. So, this is the leg of the person. So, the person is swimming and the current carrying conductor is what, at the below of the person, clear, and the current is flowing from the leg to what, this direction, from leg towards the head. Okay, this direction the current is flowing. Okay, in that case the deflection of the north pole of the magnet will be towards his left hand, clear. So, the deflection of, if I am swimming like this and the current carrying conductor is there, okay, beneath me or under me, okay, and the current is flowing from leg to head, that direction, then what, the deflection of the north pole of the magnet will be towards my left side. If I am swimming like this, then this will be my left side, or this is my left side, the deflection of the north pole will be towards my left hand side, clear. So, this is known as the Ampere swimming rule. So, I am writing this rule, clear. If a person is swimming in such a way that a current carrying conductor is conducting a current from his leg to head direction and is kept under the person, then the left hand of the person during swimming will indicate the deflection of north pole of a magnet, clear. So, this is the Ampere's swimming rule, clear. So students, hope today's episode you have understood properly, clear. Now in the next episode I will move to the next portion of this chapter. Some laws are there, Maxwell's corkscrew law, okay, then right hand thumb rule, then Weier's rule, okay. So different type of rules, and slowly we will move to the generator and dynamo and electric bell. So these portions, okay. So hope, and I will also show some experiments, okay, because if I can show you the experiments on this topic, it will be very easy for you to understand it properly, clear. So enjoy the things, okay. So physics, if you can learn it as by taking fun from it, okay, it is very easy, clear. So continue to watch my channel. So hope I will upload the next video very soon for you. Thank you.